In this video, we'll take up the second homework sheet on the word problems with linear systems. So for this homework sheet, I actually didn't solve any of the systems. The answers are provided, and I generated the let statements and the corresponding system for the question. If you have difficulties solving the systems, just leave me a message and I'll help you out. So yeah, the first three questions are all coin problems. So that's the kind of problem that most students are very good at. So I'm not going to spend as much time with it. In fact, students are really good at investment problems as well. So you can go over the system I generated and look over the let statements. But coin problems and investment problems, I don't worry as much as compared to mixture problems, for example. So for the mixture problems, the most common mistake is really just multiplying the percentage to find the amount of pure acid. Oh, well, in this case, you're looking at pure nuts. So of the 600 grams, 21% of it is pure nuts. Okay. For number two, the second mixture problem, of the 500 grams of the mixture, 45% is pure copper. And then here, of the 20 liters, 6% is pure fat. That sounds gross, but yeah. Pure butter fat. Okay. For number four, we just have a variation on it. It's pure gold. So 15 over 24 is pure gold. So you take 600 and multiply by that ratio. Of course, you can simplify this equation. Your equation could look very different, but as long as the equation is equivalent, then the systems are equivalent. Okay, of course you can remove this denominator of 24. In fact, 8, 9, 18, and 15 are all a common factor of 3. So this equation can be simplified quite a bit, but any variation of it will be you'll still generate the same solution. Okay, number 5 was from the textbook. It's a nice question. So you have 15% hydrochloric acid, 90% hydrochloric acid. You mix it together to create 60% hydrochloric acid, 20 liters of 60% hydrochloric acid. So I actually used 8% of the 15% stuff and 12% of the 90% stuff to do that. Now, this is actually the easy part. This is like the generic part. But what was interesting thing is they're actually mixing the 60% solution that you generated into the 90% bottle. So this is a little tricky. So for the 90%, did they say bottle? Let's see, sorry. Yeah, they use the word bottle. Okay, so there's 30 liters to begin with in the 90% solution. You use 12 to make the mixture. So that means 18 liters remain. So of this 18 liters, 90% of it is pure acid. And then you take the 5 liter, you add the 5 liter and dilute it a little. So you take the 60% of 5 liters is pure acid. So pure acid plus pure acid divided by a total of 23 liters, because 18 plus 5 is 23. So you go from 90% in the bottle to 83.5% because you diluted it with a 60% hydrochloric acid solution. Yeah, I really like this question because it's a little twist on your mixture problem. Then we have our rate problems. Let's see. We have the one where you're going with the wind and going against the wind. So as long as you remember speed is equal to distance over time, then these problems are pretty straightforward. And then we have the problems where there's two parts to the trip. So this is the time traveling at 150 kilometers per hour and time spent traveling 180 kilometers per hour. So this is the total time of the trip, and this is the total distance. Now 150x comes from the fact that if speed is distance over time, then distance is equal to speed times time. So speed is 150 kilometers per hour and times x is the number of hours. So this is the distance covered for that part of the trip. and the slower part of the trip, and this is the distance covered by the faster part of the trip, and this is the total distance covered. Then you have two rates. You have the plane going at a faster rate and the plane going at a slower rate. So the total distance is 850 at this combination of time at each rate, and then there's a different combination which is traveling or covering 900 kilometers. Okay, the last one is a very nice question. So when in doubt, when you're having a hard time building the linear system, I would highly recommend you to build a table to help you organize the information. So there are two trains here, Montreal to Toronto and Toronto to Montreal. Okay, so I did the speed, distance, and time for each. So using the fact that speed is equal to distance over time, then you can build the two equations. Speed is equal to distance, so y equals x over 2, and y plus 50 is equal to 500 minus x over 2. There are actually different ways to do this question, but the trick is you have to read the question. Whatever the question is, you want to assign the variable there. So the question in this, the question is, at what distance away from Toronto do the trains pass each other? At what distance away from Toronto? So if that's the case, you want to let x be your variable here, because x is the distance of how far the train from Toronto travels. Okay, because if you let x be in this cell, you will find the distance away from Montreal at which the two trains pass one another. So you don't want to solve it. You don't want to let your variable be in this cell. So you really have to look at what the question is, and then that will determine what your variables are going to be. You don't want to do an extra step, because you can solve for this distance, but then you have to do an extra step and find out what 500 minus that value is. So yeah, it's okay if you did an extra step if your system isn't as efficient, but it is good practice to build a system that answers your question, because otherwise you'll need an additional step at the end.